Okay, so far we have watched in videos and done in class looking at different types of roots, fourth root, fifth root, sixth root, how to simplify them, how to solve them. We have looked at composition of functions, solving radical equations. So now we're going to go into looking at inverses and how that's going to relate to the composition of functions that we were doing last class. So first we need to understand what a inverse is. Okay, so an inverse relationship is where we interchange the independent and dependent variables. So that means I'm going to flip my x and y values. That also means then that we are looking at two things that are reflections over the line, oops, I should say over the line y equals x. Okay, so in point form, if I just have a set of points that's a sum relationship, the inverse would be the set of points where I flip the x and the y. Okay, so again, these two relationships are inverses of each other because they flip the x and y, which means they are reflections of each other over the line y equals x. Try the second one. Now this relates to what we've been doing with composition, because we can show algebraically that two functions that are given are inverses of each other if I look at the composition of the two functions, and I go f of g of x and the other way around, g of f of x, they both should simplify down to be x. And we use the notation f inverse of x to represent the inverse function of f. So let's look at a couple of these to start. Okay, so we're going to just determine if two functions are inverses or not. So I'm going to start with f of g of x. And if, when I simplify here, if I get out x, then I must check g of f of x. But if I get out here that it is not just equal to x, then I can stop because they're not inverses of each other. So f of g of x means insert function g in for x in all places you see x in f. So that's for us going to give us 5 times 1 over 5 x plus 3. Now if I carry the 5 through, 5 times 1/5 is 1, so that gives me x, and 5 times 3, I forgot my minus 3 over here. My 5 times 3 is 15, so that's plus 15, but then I need the minus 3, that's why I just put that back in there. And that gives me x plus 12. Now because this does not equal x, they are not inverses of each other. Let's do another one. Let's look at f of x is equal to 7x plus 4, and g of x is equal to x minus 4 all over 7. So I'm going to start with f of g of x. So I'm going to insert g into f, so I have 7 times the quantity x minus 4 over 7, and then plus 4. The 7's here are going to cancel, so I get x minus 4 plus 4, which is x, so it worked on this side. Now I got to make sure that it does the other side as well. So I'm going to go g of f of x this time. So now I'm going to plug 7x plus 4 in for g. All over 7. Okay, so that gives me 7x on the top because the 4's cancel over 7, which is x. So they are in fact inverses then of each other. Now I'd like to kind of skip over C. I'm going to have you go back and do that one. I want to look at the algebra required for D because it's pretty challenging. Alright, so I want to see if f of x equals x over x plus 1 is an inverse with x minus 1 over x. So I'm going to start with my, just like on all the other ones, f of g of x. So since f has x's in two places, I'm going to plug g of x into both of them. So that's going to give me, in the top, x minus 1 over x all over x minus 1 over x plus 1. So that's a little challenging here. So I can't really simplify anything in the top yet. But in the bottom, I can find a common denominator. So I'm going to treat this as 1 over 1 and x over minus 1 over x. So the common denominator is going to be x. That means I have to multiply the 1 by x. So that's going to give me x minus 1 plus x. All right, so we now have x minus 1 over x all over 2x minus 1 over x. So I have a fraction divided by a fraction. That means I can take the top fraction and multiply it by the reciprocal of the bottom fraction. That's like just dividing fractions 101. So that gives me x minus 1 times x, multiply fractions straight across, over x times 2x minus 1. So our two x's, top and bottom, cancel. So that goes away and that goes away. And that leaves me with x minus 1 in the top and 2x minus 1 in the bottom, which is not equal to x, so they are not inverses. Okay, so I want you, before we move on, to go back and try C and see if you can determine whether or not they are inverses of each other. At this point, we have done given two functions, determining if they're inverses. Now we're going to look at finding an inverse of a function. In the beginning of the video, we said that inverses are where we flip-flop the x and y. So we're going to use that in the literal sense, and in a function we're going to flip-flop the x and the y and then resolve it for y and then replace the y with f inverse of x. So I'm going to replace the f of x right now with y, and then I'm going to flip-flop my x and y and resolve it for y. So in this case I need to divide both sides by 4, so I have y equals x over 4. So that means my inverse function is x over 4. And when you come back into class, we will look at the algebra required to show that if I do the composition like we were doing a second ago, that will in fact give me x for both of them, so they are inverses. All right, I'm going to jump down to C, and just because the algebra is a little bit more challenging, and then you're going to go back and do B for yourself. So I'm going to again replace, so I'm not doing this problem, I'm going to replace the f of x with y for now, and then I'm going to flip-flop my x and y. My goal is for this to say y equals, so that means since y is in the denominator, I need to get this y plus 2 out of the denominator. So I'm going to think of cross multiplication here, or just multiplying both sides by y plus 2. So that's going to become x times y plus 2 if I do my cross multiplication, and 3 times 1, which is 3. So again, to get y by itself, I'm going to go ahead and carry through the x. So that's going to give me x times y plus 2x equals 3. Okay, so to get the x times y term by itself, because it has the only piece that has a y in it, I'm going to say that I can subtract the 2x over, so I have 3 minus 2x. And then I'm going to divide both sides by x to get y by itself. So that means that my inverse function is 3 minus 2x over x. And again, we will show, using our composition going both directions, that these two functions are in fact inverses of each other. And it's a good way to check when you're doing these problems. But at this point, I just want you to go back to B and see if you can figure out what the inverse function to x cubed minus 3 would be.